So I think that we can start this event. Thank you for all the people that are coming and are already here. So I'm pleased to announce our Chancellor, the Professor Angelo Tagliabue, and we start this event of cooperation with the University of Alaska. So, Angelo, when you want, I think that you can start.
Direi che è una serata importante perché il nostro Ateneo ha sempre dimostrato una sensibilità particolare verso un argomento che adesso è abbastanza di moda, ma questa sensibilità arriva da molto molto lontano e quindi è sicuramente un momento in cui adesso andiamo a sensibilizzare ancora di più, perché è un evento aperto alla popolazione su un argomento che è di estremo interesse, perché leggiamo tutti i giorni di eventi atmosferici abbastanza violenti e inaspettati. Avere una finestra così fortunata. Scusa, sì. No, pensavo che era tutto in italiano, per quello che...
So our rector welcomes this event, and he says that it is very, very important for the research, for all our cooperation, and especially within the field of climate changing, and so it is very important, this cooperation.
Quindi andiamo appunto abbiamo voluto fortemente questa serata per l'importanza di quello che è il progetto che abbiamo naturalmente in questa postazione, che ci dà il privilegio di poter vedere in anteprima, di studiare quelli che potrebbero essere gli eventi non tanto di un domani lontano, ma di un domani abbastanza vicino.
So we wanted to this event so strong because of the importance of what we are studying about the forecast of what climate will do in the future.
Bene, adesso però non ci dilunghiamo oltre, non so chi prende la parola, il direttore, non so.
So, thank you very much, grazie. Angelo, and I will give I will ask to the Chancellor of the University of Alaska, the Professor Daniel White, if we can have the picture, so the image of the professor, and please, if you wanted to say some words, thank you.
Yes. Do you have it now? I don't see my picture, but is it up?
Yeah, we can see very well now.
Very good. Well, buonasera. Grazie mille for inviting me to speak with you. I apologize. I do understand Italian. I can understand most everything that's said, but my speaking in Italian is not so good. So I'll just address you in English, and I thank you very much for the opportunity to do that. For several years, 2 years, I lived in Lugano, actually Montagnola, just up the street from Lugano. So I'm familiar with your environment and the location of Insubria. Many times spent on the train back and forth from Lugano to Milano, one of my favorite cities in Europe. Also, just last year, spent a couple of weeks on Alta Via Uno. Very, very beautiful trip and a nice time. So thank you so much. Again, grazie mille for the opportunity to engage in one of our common interest, cold and changing climates. It's just now, of course, breaking dawn in Fairbanks. So while we're in different times, we're in the same environment entering winter. And for us and our colleagues around the world, it is the cold that brings us together. Myself as an engineer, of course, I've been at the university for 30 years here in Fairbanks, but only the chancellor for 7. Before that, I also studied the cold, climate, the changing environment, the hydrology, and the water resources. But it's the high mountains, the alpine, the Antarctic, those living in the Arctic like us, or the alpine like you, the ecology, the anthropology, the archaeology, the cryosphere, all these things bring us together. And as we think about it, interesting for us, the changing climate brings very different opportunities, very different environments. But it will always be dark in the winter for us. And kind of understanding what a dark environment is like in a warmer environment is an interesting challenge. And of course, there were here millions of years ago dinosaurs in the warm environment that the Arctic was still dark, and the vegetation still didn't grow in the darkness. And so understanding kind of what that environment looks like, even if it's warmer, is an interesting challenge. And I think that the challenge for me personally of hydrology and how hydrology changes in the water resource for people will be very different. So having partnerships for us is very important. Partnerships in the alpine environment, in Zubria, partnerships in the Antarctic environment, and I know you work in the Antarctic. Partnerships in the high desert. We have very similar things in common with Inner Mongolia, Lanzhou in China, even the north coast of Hokkaido in Japan is an area of sea ice, and some of the similarities in the environments created by the sea ice, also another interesting opportunity for partnership. As a institute interested in the cryosphere, we have monitoring stations all over the world in the Alpine, and I was thinking about in Zubria this morning and the Alps, the Dolomites, and the permafrost all over the world, even on Kilimanjaro in Africa. We have monitoring stations in Kilimanjaro because even there is permafrost and subject to very different hydrologic environments in the future. So I think we come together. We come together in the new MOU. It was very enjoyable to meet some of you last year here in Fairbanks, and I look forward to meeting with many more of you. I hope that you are able to come to Toolik, a special place for us here in Alaska, and also exchange of PhD students from University of Alaska Fairbanks to Insubria has experienced the expertise that is growing and built there will benefit all of us. So I'm very grateful to each of you for your partnership. I thank you for the opportunity to speak to you today, this evening for you. I look forward to many years of collaboration. Again, thank you for allowing me to address you in English. Grazie mille and buonasera. Thank you.
So thank you, Daniel, also for the few Italian words, but we understood that you know very well our area, and I think this is really important also for our cooperation in the future. And we hope to see you directly in presence maybe next year. And okay, so we are really happy. And thank you for your presentation. So I wanted to go on calling our delegate for the international relationships, the Professor Giorgio Zamperetti.
Buonasera, come responsabile dell'internazionalizzazione di questo Ateneo mi associo alla gioia di questa bella giornata. Nel 2018 la Commissione Relazioni Internazionali aveva approvato un piano che sembrava visionario da un certo punto di vista, perché prevedeva, eravamo nel 2018, di realizzare un International Branch Campus. Era qualcosa che in quel momento, ma anche oggi, pochissime università hanno, il Politecnico, l'Università di Bologna, Bocconi e Bicocca.
Okay, good evening everybody. In my role of Vice Rector for Internationalization of the University of Insubria, I would like to express my gladness to join this event that is actually an important milestone for our university. Actually, in 2018, the International Relations Committee approved an internationalization plan that actually included a list of goals. Most of them have been achieved, and one of the most ambitious was to actually to to create an important international branch campus abroad. And this event is actually confirming that this visionary task has been quite achieved.
Ecco, ora effettivamente quel, tra virgolette, sogno sta diventando realtà, e per di più in un settore così sensibile come quello del cambiamento climatico. Ricordo che quando con il professor Guglielmini e la professoressa Cannone presentammo questo progetto, io non ero sicuro del successo dell'accoglimento da parte del Ministero, tanto appunto sembrava avveniristico per un'università giovane come la nostra. E poi ricordo le lunghe telefonate con le nostre rappresentanze diplomatiche, le lunghissime riunioni per cercare di definire tutti i dettagli per un'impresa che obiettivamente ci faceva uscire dalla nostra comfort zone.
As said before, this is a dream that is becoming reality, and especially in a field such the climate change, which is fundamental and so important for the life in this troubled planet. Professor Zamperetti remembers that when Professor Guglielmina and Professor Cannone submitted the project to our Ministry of Education, he wasn't sure that to succeed in this proposal because it seemed too maybe too futuristic for a young and medium-sized university like ours. But he remembers as well the long calls with the Italian embassies and consulates that are actually actors in this project, but and all the endless meetings that have been performed to achieve this goal.
Ecco, naturalmente questo non è un punto di arrivo, ma è un punto di partenza, perché tante cose devono essere fatte. Soprattutto questo progetto deve essere reso sostenibile economicamente, perché diciamo il Ministero e la nostra governance hanno finanziato, ma sarà, diciamo, i risultati che otterremo in questo progetto che ci daranno le risposte su questo tema.
Okay, so this is a starting point, not a final point. We just started with this project. Many things must be done to develop the project and make it sustainable on the financial point of view, and in terms of a long time cooperation. So it will be the results that we are able to achieve that will give us a real answer about what we are looking for.
Okay, ringrazio l'Università dell'Alaska Fairbanks e il suo Chancellor per essere stato un partner affidabile e costruttivo, e per avere creduto nella capacità dei nostri ricercatori, che peraltro hanno una reputazione di alto livello.
So Professor Zamperetti thanks the University of Alaska and its chancellor for being a reliable and constructive partner, and for believing in the abilities of our researchers, who also have an excellent reputation worldwide.
Okay, some words for Professor Chancellor White. I was surprised to know that you know our beautiful region lake, and really we wait you, Como e Varese, to build our relationship, our lasting relationship between our institution. So thank you very much, Professor White, and everybody. Thank you.
Thank you, Giorgio. So now I wanted to introduce our general manager, the Dr. Marco Cavallotti. Marco believes a lot on this project because last year was with me in Alaska, and I wanted to thank personally not only you but obviously also the Chancellor.
Grazie per avermi riservato dello spazio in questa occasione. Ringrazio il rettore dell'università dell'Alaska per questa opportunità. Io sono stato in Alaska lo scorso anno proprio per approfondire quelle che possono essere, che dovevano essere gli aspetti amministrativo, contabili, giuridici, insomma la parte più noiosa, burocratica dell'operazione, ma questo è il mio mestiere.
Okay, our general director thanks the University of Alaska and his rector for cooperating with us, and he's very happy for this event. He says that he visited Alaska to make this cooperation real, on the administrative and financial aspects, and
più in generale, oltre a diciamo nel mio ruolo devo riuscire a mettere a terra quelle che sono le iniziative dell'Ateneo in tema di sostenibilità, sia sotto l'aspetto di formazione, ricerca, terza missione, quindi di trasferimento delle conoscenze al nostro territorio, e una quarta missione che non è declinata formalmente dal Ministero, ma che l'università si è data, che è quella di avere un ateneo sostenibile.
In my role of general manager of the university, I have, let's say, three main tasks that are to boost research, training, or, well, teaching actually, and the knowledge transfer to our territory. But I have a fourth task that actually is la
Quarta missione,
missione,
che è la sostenibilità dell'ateneo.
Sustainability
Generale.
of our university, of our institution.
Noi come Ateneo mettiamo la sostenibilità al primo posto e lo si vede a partire dalla nostra home page, dove si possono trovare tutte le iniziative che l'Ateneo mette in atto sui diversi aspetti della sostenibilità, su tutte quelle che sono le azioni che sono state programmate a livello mondiale per quanto riguarda la sostenibilità.
So sustainability is something very important for our institution. As you can see from our homepage of the institutional website, where all the initiatives that we carry out in to this goal are present.
E l'università interviene sui 17 obiettivi, su ciascuno dei 17 obiettivi che sono stati individuati, e promuove azioni per tutti questi obiettivi.
The university intervenes relating to all the 17 ESG goals, and we try to go on and to complain with complain with these goals.
La nostra responsabilità è ancora più grande se consideriamo il territorio in cui siamo, e se ci basta vedere questa immagine per capire la posizione dell'Ateneo, che è al centro di quella grande macchia luminosa che identifica una zona densamente urbanizzata, densamente ricca di industrie, produttiva, e di conseguenza con i conseguenti problemi legati a una sostenibilità complessiva. Quindi l'Ateneo ha una grossa, e si sente questa grande responsabilità nell'affrontare questi problemi per contribuire a un futuro più sostenibile.
So our institution has a great responsibility towards sustainability, because as you can see by this map, we are actually in the center of the most enlightened area of northern Italy. So this is a region where a great number of industries, companies, and anthropization is present. So this is why we have a great responsibility towards sustainability.
Contiamo anche su questa collaborazione per individuare tutte quelle che possono essere le soluzioni possibili, affrontabili e sostenibili sotto tutti gli aspetti. Grazie.
We strongly rely on this cooperation for all the solutions that could be found to deal with the climate changes and let our region and our area more sustainable and more green.
So thank you very much, Marco. Also because you introduced one of the more important aims of our university, so the sustainability. So now we change a bit the format of the presentation, because we started with the presentations, and I wanted to invite the Professor Sindonia Bret-Harte, that we can't see now. So Donie, if you wanted to start with your presentation, nice to see you. So Sindonia, the Professor Sindonia Bret-Harte is the responsible for the Memorandum of Understanding, the scientific responsible for the Memorandum of Understanding that we signed this year, and but she is also the responsible for the Toolik station. So with her presentation will give us the main elements about the Toolik stations, but also about one part of the Memorandum of Understanding that we signed this year. Please, Donie.
Thank you, Mauro. Buonasera e grazie mille. And I'm afraid that's all the Italian that I know, so I apologize. I will have to speak in English. I wanted to talk a little bit about some opportunities for Italian students through the MOU. And UAF, University of Alaska, Fairbanks, offers many opportunities to learn about and work on boreal and Arctic ecosystems, permafrost, effects of climate change, as Chancellor White mentioned, the cryosphere, and how people can adapt to live in our changing climate. The University of Alaska Fairbanks offers both master's and PhD programs, and there are also many courses online by experts who are known the world over for their work on these things. And so one thing that is offered by the MOU is the possibility of exchange for Italian students to come and work in the labs of individual UAF faculty as part of getting their degree at Insubria. And also there's an opportunity for UAF students and postdocs to exchange to work at Insubria University. And so, for example, you could consider comparing the climate change effects on vegetation in the Alps and in the Arctic. And this is something that I've been talking about with Dr. Canone, and my recent PhD student has written a postdoc proposal to do that. And also, Mauro and Nicoletta talked with us about maybe setting up a dual master's program in the future, which is something that we are excited about. And because I'm in the Department of Biology and Wildlife, I wanted to give you just a little background on that department. We have 32 faculty who cover a wide variety of disciplines, not just ecology, but also in genetics, biomedical degrees, et cetera. And we offer online, in-person, and hybrid degree programs and classes. And so please check out our website if you're interested in learning more about the classes that we offer. And I don't have as much detailed information, but the UAF departments of chemistry and biochemistry, physics, geosciences, and atmospheric science all offer additional options for thinking about climate change and its effects. I wanted to mention a little bit about Toolik. So you see here, UAF is in Fairbanks, which is in the center of the state of Alaska. And up above the Brooks Range, in the northern foothills of the Brooks Range in the Arctic, is the Toolik Field Station, which is a leading year-round Arctic research observation and education facility whose vision is to provide insight to address local and global challenges in a rapidly changing Arctic. And our mission is that we promote greater understanding of the Arctic by safely, sustainably, and equitably fostering research and education in response to the needs of scientists and society. We are part of the EU-funded Interact program, which had put together this nice graph that shows in the environmental space, the two axes on the bottom is mean annual precipitation, and on the side, the y-axis is mean annual temperature, getting colder as you go north. And so you can see that Toolik is located in the zone of continuous permafrost in northern Alaska and has a tundra vegetation. Toolik itself was founded almost 50 years ago. We're coming up on our 50th anniversary celebration in 1975, when an intrepid band of scientists traveled south from Prudhoe Bay looking for a lake that was deep enough to have overwintering populations of fish. They had been working as part of the International Biological Program on the coast in the shallow ponds and permafrost that's there, and they were looking for something a bit different. Today, we have a large facility. We're actually the largest research station in the Arctic, with modern housing, modern laboratories, and just really everything to be a self-sustaining little village. And why do people work at Toolik Field Station? Well, it provides access to a wide variety of Arctic ecosystem types, the Brooks Range, the Northern Foothills, and the Arctic Coastal Plain. And because we're on a road, we're accessible and we're efficient. We have really good logistical and technical support, and we've been open year-round since 2006. People who are working at Toolik study a wide variety of systems of interest, including, of course, the ecology of the tundra and freshwater ecosystems, but also things like the Anaktuvuk River fire, which started in 2007 and was an unusual event in tundra. Also thermal erosion, thermokarsts, and also totally different space physics. Folks are interested in the aurora and what happens to the winds in the upper atmosphere, how they're changing and how that affects space weather, which is very important to keep the satellites from colliding. And of course, climate change is very rapid at high latitudes, so we have a strong interest in the fate of all the stored carbon that's in northern ecosystems, both the boreal forest and the tundra. We have collaborations with national and international researchers, and we were very happy to welcome Dr. Guglielmin and Cannone and their project from Insubria this year to work at Toolik for 2 years. We have a lot of long-term whole system ecosystem experiments and observations. And because of our just fortuitous location, we have a lot of ecological and environmental gradients that you can study while you're there. And so we're at the center of several big observing and research programs, including the Arctic Observing Network, the National Ecological Observatory Network, the LTER Network, and of course the Interact project. We offer quite a lot of science support if you are working at Toolik, and that includes our Spatial and Environmental Data Center. You're going to be hearing a bit later from our Environmental Data Center manager, Amanda, who will show you a video of Toolik. And that group does a lot of both abiotic and biotic monitoring and provides a lot of field assistance and remote access and provides common use equipment. That group also includes GIS and remote sensing, and so we can help you with site selection and permitting, with spatial data collection and analysis, including from UAVs or drones, and map production. And then we also offer assistance with maintenance and equipment fabrication, including creating sampling tools and providing support for autonomous power systems. And of course, we provide excellent food, transportation, and shipping to Alaska, to the Toolik Field Station. And here's just some examples of that field assistance that we offer, including setting up meteorological stations, downloading them and troubleshooting them. We make measurements of phenology, which is the timing of life events in vegetation and in animals. NDVI measurements, we do help with river discharge, soil sampling, thaw depth measurements, etc. And this graph just shows how the number of projects has increased over time. We support between 350 and 550 scientists and 70 to 100 projects every year. They come from across the US and internationally, and they've produced a lot of articles, many of which are in scientific and high impact journals, and we have a lot of outreach as well. And all of this, you can get more detail from our website. Another thing that's really important to us is that we're working to create a community of respect to ensure that the Toolik Field Station is diverse, equitable, and welcoming to all. We have a code of conduct and multiple reporting pathways to help us prevent and rapidly respond to misconduct. We've recently created a community gear closet to reduce barriers to access for people who've never been to the Arctic before. And we work really hard to use communication to build a sense of belonging and inclusion. We also offer, we prioritize safety with a holistic view of field safety. We make safety gear and training for all residents available, and we have mental health first aid training for our staff. We have an EMT on site in the summers when researchers are at the station, and in the winters when there's a lot of researchers. And I just wanted to show this a little bit about station occupancy near the end here. So these graphs, the blue shows the scientists, and then the others are construction personnel that help with logistics upgrades, and of course our staff, including the basic staff that help with logistics, operations, and maintenance, and then also our SEDC staff. And at this point, we had a bit of a dip when COVID first happened, and we had to close the station briefly. But now our station population has returned to pre-COVID numbers, and researchers are coming earlier and staying later in the shoulder seasons to address the critical gaps in our understanding of Arctic change, including the Insubria group, which is going to be there until November. And this just shows our station occupancy, and you can see that most people come in the summer, but we have a lot of opportunity to come in the winter also. And so we welcome guests who want to do some research in the cold Arctic night. And that is the end of my presentation. And grazie mille, and welcome to Toolik Field Station and the University of Alaska Fairbanks.
So thank you, Donnie. Now I will try to go on with the presentation of our project and of our memorandum of understanding. Just to
yes, we can see it. Thank you.
Okay, thank you. So this is just a picture of the travel that we did last year with Marco and also with the students, because one thing that we didn't tell is that thanks to the our international relationship, we did also a travel with a selection of 10 students last year of all the different faculties that we have, and we visited Alaska. Obviously, the trees had different colors of what we saw this year. So one of the reasons because we started and we decided that Alaska was one of the best places in the world to do this project is because the climate change is changing not only the climate but also the landscape. And in particular because in areas like Alaska or the polar areas, permafrost, so the perennially frozen ground, is now thawing. And this permafrost thawing induces different effects on the landscape, like the formation of landslides in our Alps, or thermokarst or coastal erosion in Alaska, for example, and also very important effects on the hydrological changes, more lakes, for example, in Alaska, but even drier areas, that is exactly the opposite in other polar areas like the Antarctica. But above all, the methane and the CO2 are increasing their emission from the ground that is thawing. What our university is doing since more than 20 years ago, in reality, in all the blue dots that you can see in these two maps, one on the boreal hemisphere and one in the southern hemisphere, are the places in which our university have some perennial or long-term monitoring station, not only to monitor the permafrost changes, but also the carbon fluxes and the vegetation changes in terms of coverage and the composition, but in the last presentation of today, we could have much more details about that. So in this sense, we are lucky because we have, as you can see in these pictures, a quite nice latitudinal transect in the southern hemisphere. We are the only university in the world that we can have 4 different sites between 74 and 60 degrees south. And we have a couple of sites in the Alps and in the Svalbard Islands, together with the National Research Council, Italian National Research Council. But now the new star, the blue star, is in Alaska. And Alaska is very important. Why? Because it's one of the 3 areas in the world in which the air warming was greater in the last 100 years. So, in some sense, we have different sentinels of what is happening in our Earth, and we have the honor and also the difficulties to manage all these monitoring stations. But we hope that the cooperation and the expertise of University of Alaska, the Green Star can become the more important of this network. So in detail, the project that was funded, as Professor Zamperetti mentioned, by the research ministry and above all by our university, aims different things, but in particular to favor the international relationships with the exchange of students, with the exchange of PhD, with the postdoc, or with the promotion and the creation of new master courses with the University of Alaska, but also to increase our scientific productivity. And the University of Alaska is one of the, at least on the climate change effects, is one of the most important university in the United States. So for us is very important to start this cooperation. The Memorandum of Understanding was signed in 1st of May of this year and is valid for the next 5 years. And in terms of research, the ongoing projects now are focused only on the monitoring of the fluxes, the carbon fluxes, the relation between the vegetation, the climate, and the active layer thickening. But in the future, we hope that also other professors, other people in our university, and also in the University of Alaska can cooperate to develop other research topics. One of these is already started, because also the microbiology that is a part of the monitoring of the fluxes is already started with this year. And we have also here in the classroom the Professor Marinelli that is the responsible for this part of the project. Regarding the teaching, as Donnie mentioned, we have already started to think about a possible master thesis in climate change, sustainability, or something like that. But obviously, the way to reach this kind of goal is longer than to start with the project like what we did. So what we have already done, we establish a place in the Toolik, in the station of the University of Alaska in Toolik, and since the 25th of April, a couple of our PhD students and students started, but then during the period you can read by yourself. We have several people, a total of 9 people from among the researcher, the PhD, the master students, and professors. And we started this project in terms of snow monitoring, obviously in the first part of the season. Then we started to select and install the carbon fluxes and vegetation monitoring. And together, and thanks the logistical support of the GIS unit of the Tulik station, we did also the flights with the drone with different cameras in order to map not only the vegetation but also the permafrost thawing. The activity of this year will finish on 9 of November. Now we have 4 people that in a few minutes we could see. We could have a direct connection with them. And in detail, just to show some images of what our students and our researchers are doing is, for example, the snow monitoring. You can see that there is not a lot of snow in Alaska, as many of the people can imagine, because Alaska is a desert, so there's not a lot of snow. But the snow can remain for many months during the year and can change completely the temperature of the ground and the condition for the vegetation development. So for this reason, small changes in areas like this one are much more sensitive, are much more important than in other areas. And this is one of the reasons because we need to go there. Regarding the permafrost monitoring, we did some boreals, 8 boreals. You can see that are very shallow boreals, less than 1 meter, because here the frost table, so the ice in the ground, you can't see. If you see this image that are during the summer, we have grasses, shrubs, plants, no ice. No snow. But if you drill at 20 centimeters, you have ice. And this is one of the reasons because you can see the grasses in a desert, because there is ice that is impermeable and all the water can remain in this very short part of the ground. 8 boreals are enough to understand the active layer thickening during the year, monitoring the temperature and the moisture. But to have more reliable areas, thanks to the drone image that our American colleagues did for us, our students made on the dots that you can see with the different colors, they use a very simple method to understand at what depth you can find the ice. And with this frost probe, it is a kind of steel nail that you have to press down on the ground. But we started also, probably the more important part of the project, that is the carbon fluxes. You can see the chambers and the instrumentation that we bought thanks to this project. And this kind of chambers, in the chambers, we are monitoring all the parameters, so the solar radiation, the soil moisture, the air temperature, the ground temperature, and also the methane, the CO2, and also the water fluxes, because it's really important to remember that water is another greenhouse gases that the people doesn't think that there is also the water. But the vapor water is another greenhouse gases. Obviously, because there are several changes and also fast changes in the vegetation, as also Donny mentioned, and after in the last presentation we see there is also vegetation phenology, measurements and mapping, but also when we did the boreals, we take out the course, and on the course, one of our PhD is doing biological analysis to understand which is the microbiota that produce the carbon fluxes, or and the variation of this microbiota, because the sampling was done 2 times during the year. So this is a very short image of what we have in mind to do in the next year. That is the same activities in a little shorter period, because we saw that now all the instrumentation are already installed there, so we don't need a period to understand the instrumentation and to install the instrumentation, and so we shorten a bit the period during the snow coverage. And we have also the idea to understand better the feasibility of other activity around Fairbanks that this summer we visited together with other professors of University of Alaska, and also at Barrow, where originally we thought to do our branch. So as Donny mentioned, the first step of cooperation was the Marie Curie proposal, the postdoc Marie Curie proposal of the Dr. Jackson Drew, with the supervisor, the Professor Cannone. And as Professor Biasini knows, also we did a participation, not in presence, but a participation to an initiative that the Swiss embassy joined with the Italian embassy and the other alpine countries' embassies in the United States, in Washington, we did just last week. And thank you for your attention. And so now I want to invite Amanda Young from Tulik. Can you hear me?
Yep, I can hear you.
Okay.
Thank you for
nice to see you again.
Thank you for having me do a little presentation on a video. It's going to be a bit of a life at Tulik, which I can see there in the crowd, Laria, Francesco, and Sylvia, so they'll have experienced much of this. And I will share my screen, and hopefully it will.
Thank you, Amanda, for the overview of the Tulik scenery and the Tulik station. Do you want to add some more?
No, Tulik's a great place, and that was just a taste of it. So there's so many more things and animals to see at the field station. So come on up, and we'll show you all the sites.
Okay, in just case, we can go directly in the field with our students. So I wanted to... Possiamo shiftare sull'italiano, eccoli lì. Io li accoglierei con un applauso già adesso perché...
No, ragazzi, aspetta.
Buongiorno.
Buongiorno.
Ciao a tutti.
E buonasera.
Sì, per noi buonasera, sì, lo so che per voi è mattina. Allora, cosa ci raccontate di bello? So, what do you want to explain of our activities? Because maybe the people don't know that our team is an international team, also the team, because we have also an Indian PhD, that is Dr. Vasudha Chaturvedi. And unfortunately, she doesn't speak Italian until now, so maybe we have to shift again in English. Okay? So, what do you want to start? So, what you can show us?
Okay. Today, me and my colleagues will be showing you what we do on the field on everyday basis. So, me, I'm a PhD student in my second year with University of Insubria, working under Professor Mauro Guglielmin. Okay, so my work, what I'm doing over here is measuring methane, carbon dioxide, and H2O fluxes, because as we all know that Arctic is changing, and what we are trying to do with this project is trying to analyze and understand over the course of time, how are these fluxes changing? What we are also considering is variables that are affecting these fluxes, like vegetation, soil moisture, soil temperature, and active layer thickness. So I'll just give you a peek look on what we are doing with the instruments. Okay. So this is one of the prototypes of the closed chambers we are using. And that's the state-of-the-art instrument, LICOR. That is methane, carbon dioxide, and H2O. And on the field, can you zoom in?
Yeah.
Okay. So here are the instruments that we also use for measuring soil temperature and moisture with the fluxes, because these are the environmental variables we are looking upon, and also the vegetation on the side. So how we start with the measurement is recording all these instruments with the soil moisture, temperature, and vegetation, and the methane fluxes. So that's how we start with the measurements for the day. And for the remaining vegetation type, my colleague Chiara will introduce you about this.
Hi everybody, I'm Chiara, I'm a PhD student at the University of Insubria, and I work on vegetation with Professor Nicoletta Cannone. The sites here in Tulik are free and are different. There is dry tundra, tussock tundra, and wet tundra. And there are different types of species in the vegetation and also in communities. And what is how the vegetation impact the fluxes on carbon dioxide. And what we do here is the phenology monitoring. So we study the growth of the plants, of target plants, that my colleague Ilaria, that now is in Varese, found when she was here. And what we do is understand in which phenological phase that plants are, understand which is the correlation with the phenological phase and the carbon dioxide fluxes. Another thing that we do here, and we did, is the vegetation map of the Insubria site area. I thank Ilaria to did some releve, and thank Nicoletta to did other releve. And what we try to do is to understand which vegetation community are along the area and along the transect. Now, I would to present my colleague Filippo that speaks about permafrost. He is a master student.
I am Filippo. I'm master student in environmental science in Subria. Right now I'm working on my thesis with Professor Mauro Guglielmin. Here I show you about some analysis of the active layer thickness. So we are right now using boreals, as mentioned before, and we are monitoring soil temperature at different depths, starting from the ground surface temperature. These boreals are in each plot of the measurement fluxes, and we want to compare this kind of data with the one of the fluxes, because we expect that higher temperature match with the higher methane fluxes emission and also carbon dioxide. Here I show you just a simulation of how the boreal works. We are the data logger that are working on the field right now. So now we are just using a simple thermometer. We measure the ground surface temperature, like 2 centimeters depth. And now we are making stabilize the instrument. Right now we are measuring a value of minus 0.3 Celsius. And this is because right now the temperature in the end of the summer are dropping down. So the active layer is starting to froze from the upper part. Some dynamics are like that. And we use also another simple instrument to study the active layer. This is for outside the boreal. So we use the frost probe. This is it has sign every centimeters. So we use it to reach the top of the ice part. Right now I can't show you here because this is dry heat tundra. It doesn't work pretty well, but in the Tastock side and the wet side, it's kind of really good instrument. So now I shift to Lorenzo for the other data.
Hello, I'm Lorenzo. I'm first year PhD student in life science and biotechnology in the laboratory of microbial biotechnology of Professor Flavio Marinelli. And here I'm conducting some metagenomic analysis on the active layer and permafrost microbiota. So to do this, we perform some boreal to obtain some core and have the material to where perform this type of analysis. To perform the course, we use this 1 meter long Auger soil collar, and from this we obtain the core itself, and I can show you here. Basically, what we're going to do on this core is define the different horizons that we can see. For example, here more or less we are 3 horizons. The first part with litter and vegetation, the second part with clay, and the second part with mostly organic matter and sand. So to understand the role of the microbiota, is very important to understand also the greenhouse gases fluxes that are released from the permafrost thawing, and because the actual production of methane are key. That is a particular type of class of microorganism that are involved in this biological process. So we are monitoring the microbiota in different type of tundra, as described before, in Tastock tundra, wet tundra, and tight tundra, and also in different periods. So we performed the first coring period in between June and July, where it was supposed that the active layer thickness was the minimum, and the second coring period was performed a couple of weeks ago in September, where the active layer thickness is supposed was the maximum. So then we're going to try to understand how the microbiota change and who has the most important role in greenhouse gases emission. So now we can continue showing you the our measurement on greenhouse gases fluxes. So
So after a couple of minutes of measurement with the sheet and with the application that is provided by the state-of-the-art LICOR, we make measurements of CH4, CO2, and H2O every 15 minutes. That's how we're trying to estimate how all the variables that my colleagues talked about, how they are contributing to all these fluxes over the period of seasons. So starting from April, May, when Sylvia and Francesco were here, till the time till November, so when all of us are here. And I think that's all. Yeah, this is the view of how the fluxes look like.
Nice. Can you see? That's
Oh.
okay. This
This is for the dry heat.
No!
Mettici due che possono.
Non va.
Okay.
Okay,
Doesn't work in this
So,
moment.
no, we saw that you have 2,000 parts per billion of methane, but I'm not an expert, but it seems quite a lot.
Quanto?
So
Yeah.
okay.
You're here.
We are right now on the dry side of the vegetation. For the time being, the environmental reference and the methane fluxes are high as compared to the summer period. And we are expecting that why has it happened? Because right now the active layer is at its maximum thickness. But vegetation is in senescence period. So I think that's what is causing freezing of the ground is causing methane values to be high right now as compared to previous period of the summers, which was actually around 1900 parts per billion.
Okay, thank you, Vaso. But just to know, which is the air temperature now?
Minus
-5.
five.
now.
Ah, so it's quite hot.
Yeah.
In compared to yesterday, yeah.
Okay. So I think that I wanted to ask to stay connected, but now we have the last scientific presentation, not the last for this evening, because the closing presentation will be done by Professor Biasini. So I will ask after these two next presentation to the people that are here if there are any questions for you. So remain connected. Okay, so and see you in 20 minutes, 30 minutes. Okay, so I wanted to bye.
Bye.
So the last scientific the only presentation, scientific presentation, just to give also a scientific sense to the event, will be given by the Professor Canone.
Okay, it's working. Okay, thank you for coming here, and thank you for... No, but I think it works. Lavora, giusto? Si sente? Okay. My presentation will be an overview of the scientific topics that brought us to cooperate with Alaska University of Fairbanks, but also to establish other international cooperations and scientific research on the topics of climate change. In particular, as Mauro mentioned before, now climate change is a problem that we can't ignore because air temperature increase with a rate and with a rapidity that is not known in the history of our planet, because you have to consider that in the past our planet experienced a period of very strong warming, but this warming was achieved in thousands of years, not in less than 150 years. So the rate of change is very, very strong, is without any previous event of this magnitude in the planet. And this means also that the abiotic and the biotic systems, the species, the living organisms are not adapted to this kind of change. This means that First of all, we have an impact on the abiotic part of the ecosystems, and in particular on the cryosphere. And then, as Mauro told, these impacts affect permafrost, its distribution, its temperature, the active layer thickness, so the thickness of the upper part of permafrost that melts during the growing season, during the summer. And this affects also the water, the hydrology, so the water distribution, the water accumulation in the ground, the soil characteristics, and obviously what grows over the soil or within the soil, so the vegetation. And the permafrost changes and the vegetation changes create also consequences on the functioning of the ecosystems, in particular on the degradation of the dead organic matter that is accumulated in the ground year by year, and in this case, like in tulic areas, since thousands of years, because this area has been deglaciated since thousands of years. So we have thousands of years of accumulation of organic matter, and we have a particular kind of sediments that are called eudoma that include a very large amount of organic matter, which could release huge amounts of greenhouse gases during their degradation. And obviously, the changes of the abiotic components that are triggered by climate change, so changes not only of air temperature but also of the precipitation regime, of snow cover in particular, trigger changes of the biotic components. Obviously, there are areas in which these processes are more evident. Which are these areas? Are the areas characterized by cold climate, so high latitude, so polar areas, Arctic, Antarctica, but also high elevation areas, so mountains, like our mountains. In particular, Alaska, the European Alps, and the Antarctic Peninsula are the three areas of the world that experience the strongest warming since 1950. So we are in the core of the problem. Concerning the biotic components, which are the main problems or the main effects that we can expect from climate change impacts? The responses could be different because we could have changes of the physiology. Obviously, if we are exposed to an uncomfortable condition, to high temperatures, what firstly happens is that we can't feel fit. So changes in the physiology, and then changes in the phenology, so in the seasonal cycles, in the seasonal responses of the species. Then changes of the distribution, of the spatial distribution of the species. Species tend to migrate. Who is able to migrate comes in other areas trying to find conditions that are suitable for life. If you can't migrate, you could die, or you could migrate through your seeds, like do plants, because plants having the roots can't move, can't migrate like animals, and plants in this case are the best bioindicators of climate change, because if they are able to survive in site where they are growing, this means that climate change is not so strong. But if they start to change their distribution through their seeds, so their descendants, this means that the impacts of climate change are very strong, and they can't survive where they usually grown since probably thousands of years, like in tulic. And then you can have changes of composition of the communities, structure, but also changes not only at the level of the single species, but of the landscape. So changes that go over the ecological hierarchical level of species that include all the ecosystems and above all their functioning. We saw these changes, not only our university, our research groups, but globally. These changes affect three main areas in the world, so the polar areas, the Arctic and Antarctica, but also the alpine areas. Here I will speak about what is going on in the Arctic and in Antarctica, especially in Antarctica, because we started to work in Antarctica more than 20 years ago, so we have a long-term experience. And we are trying to create a research network across the most sensitive areas affected by climate change. In the Arctic, you can see this is a picture from Ny-Ålesund, the Svalbard Islands. Obviously, Arctic and mountain areas can show a biotic response of climate change. This is a change of vegetation composition because we have species migration. In particular, there are two kinds of main responses. One in what we call the cold tundra, so those located at the highest elevation or highest latitude, we have an increase of gramineal plants. But in the warm tundra, so in not so high elevation or latitude, we have a global trend that is shrub and tree encroachment. Shrub and tree encroachment is affecting large part of the northern hemisphere. It is very rare in the southern hemisphere, but it is due to the distribution of the land masses and respect to the oceans. And you can see here an example of the dots where you can have an increase in recruitment, so in the growth and survival of shrubs, and the advance of the shrub line, so in the areas in which shrubs occur. And this is another example that has been taken from Alaska, but we have examples in all the Arctic and subarctic areas of the northern hemisphere in particular of shrub encroachment. And this changes not only the structure of the ecosystems, because we shift from herbaceous ecosystems to shrubby or forest ecosystem, and this affects also obviously all the landscape, because we have a big change at the landscape scale, but also the species, and in particular the food web, the processes of organic matter accumulation in the ground, and obviously of the degradation of the organic matter, and so the release of the greenhouse gases. These processes that, as I told you before, affect first of all the abiotic components of ecosystems have a domino impact, a domino effect of feedbacks that are in most cases positive feedbacks, so are consequences that increase the drivers and the triggering factors of climate change, so go to amplificate, to increase climate change itself. And there is a very clear relation between what grows above ground, so vegetation through the net primary productivity, the soil conditions, and the output in terms of release of carbon dioxide and methane. Obviously, permafrost is a very critical issue because where we have frozen ground, so permafrost, the dead organic matter that is accumulated within the ground remains frozen. This means that the microbial components that occur in the ground are not able to degrade this organic matter. And so we don't have any release or further release of greenhouse gases. When permafrost starts to melt or permafrost temperature increases, this means that the organic matter that is stored in the ground starts to get unfrozen. So the microbial part, the microbial biota that is in the soil is able to degrade it. If the degradation occurs in a dry environment, we have oxygen, and so we have the release of carbon dioxide. If we have water that remains in the ground, we have anoxic conditions, and so the release of methane. For this reason, we are measuring both carbon fluxes, so the fluxes associated to carbon dioxide and those associated to methane, because these are two very important components of the greenhouse gases. And you have to consider that the greenhouse power of methane is 25 times stronger than the power, the climatic change impact of carbon dioxide. But this process is not so clear, is not so linear, is not so simple. Why? Because we have a lot of different factors that interact. So We don't have simply the vegetation, the duration of the growing season, the snow cover, the amount and type of organic matter, because also the dead organic matter that is in the ground is not the same everywhere. The capability to be degraded depends on the type of vegetation, on the chemistry of the soil, on the macrobiota that is occurring in the soil. So there is a lot of interaction and complexity in this kind of situation. And this means that we are not sure whether climate change could turn the Arctic or mountain ecosystems in sinks or sources of greenhouse gases. And this is the reason why we need to increase and improve the research and to have more data on the carbon fluxes across a very different kind of environment, locations, latitudes, elevations, because increase the data set allows to understand better what is going on and provide models to forecast what may happen also in the future. Oh, sorry. Here we have an example of the work that we have already done in the Svalbard Islands, and we are still doing also in the Svalbard Islands, using both plot scale measurements of CO2 fluxes as well landscape scale measurements with the eddy covariance that you can see here. Okay. And now we tried to started with a cooperation with the University of Alaska Fairbanks. We started to do this also in the Arctic in Toolik. As I told you before, our research activities on climate change started more or less almost 25 years ago in Antarctica. And you would say, Antarctica is the icy continent. Why are you studying climate change there? And what can a botanist do in Antarctica? We can do a lot of things, because as you can see in this work on the bryophytes, so mosses that are one of the type of plants that occur in Antarctica, we show that Antarctica is rich of biota, of mosses, of lichens, and the Antarctic biota is a very peculiar biota because it has been selected by a long-term evolution, 25 millions to 30 millions of years of evolution, because the isolation of the Antarctic continent is so long. And you can see that in Antarctica there are some patterns of distribution of these mosses that are in particular in some parts of Antarctica, while other parts of Antarctica are very poor of biota. And this fact was very strange for us, because you could see the icy continent, it seems the same everywhere, but with our colleague Serena Zaccara, in the frame of an international collaboration with the British Antarctic Survey and the University of Canarian, we demonstrated that using molecular tools to analyze these Antarctic mosses, that in reality Antarctica was connected with the other parts of the world, and that during past climatic changes, in particular 3 million of years ago and 1.5 million of years ago, we had massive invasion of Antarctica of these mosses coming from South America, but the ancestors of these mosses came from Europe. So a long, long travel that these mosses made to Antarctica. And this is the witnesses, the indication that past climatic changes that occurred over a very long time with rates much lower than what is happening now had a very strong impact on the biota of this fragile continent. But if we go to what is happening now, is Antarctica a site where we can see what is going on, if there are impacts of climate change? If climate change is occurring there, yes. In Antarctica, climate change is occurring, and in particular in the Antarctic Peninsula, but now also in the continental Antarctica, that all scientists until 10 years ago said that was totally divided by climate change and that there was impossible to detect climate change in Antarctica. Our research group demonstrated that even in continental Antarctica, climate change is occurring with changes that affect permafrost, active layer, and the vegetation, even in continental Antarctica, that we can detect even in a short time, so in 10 or 15 years of monitoring. But we also demonstrated that these changes that are occurring and are related only to the impact of climate change, because in Antarctica we don't have any other driver. We don't have land use change or pollution, luckily, or other drivers. Even the soil conditions are changing with a striking alkalinization of the soils that we detected in the last 10 years due to permafrost degradation, to the active layer thickening, and to the hydrological changes, even in this remote continent that is a polar desert. Even here, you can detect very important impacts. And for this reason, we also started to simulate the potential impacts of the future climate change by manipulation experiments that are inserted in the frame of the International Tundra Experiment. So these are 5 of the sites located along this latitudinal transect from 77 to 73 degrees south, and it is a unique transect that only Subria University has, so only the American and the Italians can show such kind of monitoring network in Antarctica. I'm very proud about that. And we also work, obviously, with other colleagues, with our colleagues of the British Antarctic Survey, where we started in 2001 this long-time collaboration that is still ongoing. And we had a very important research site at Signy Island, because the colleagues of the British Antarctic Survey started to study this part of Antarctica that is in the Antarctic Peninsula, close to the Antarctic Peninsula, so close to the South America, since the 60s. So they have 60 years of monitoring, more than 60 years. We started to see that something was changing in this part of the world, and indeed the Antarctic Peninsula is one of the 3 areas experiencing the strongest warming. And now we had a very big occasion and chance, and we are very proud because we succeeded in publishing this paper that stated that the acceleration of climate change is now detectable also in Antarctica. The acceleration of climate change has been detected and demonstrated in the Northern Hemisphere, in particular in Europe, but before this paper, nobody could demonstrate that climate change is accelerating its impacts also in Antarctica, where you can see a very strong warming, the orange dots, in the last 10 years, that correspond to a spread of these 2 native species of vascular plants that are the only 2 vascular plants native in Antarctica. All the other plants are mosses and lichens. But obviously, the warming of climate creates also the opportunity for plants coming from other latitudes and other geographical regions to invade Antarctica. Antarctica is very fragile, and you can see the example of this Poa annua. Poa annua is the grass that you can find in the golf field, and this Poa arrived at Signy Island, and it was far more than 2,000 kilometers from any other site when this plant is known to occur. And with the molecular analysis, we demonstrated that the haplotypes, so the molecular characteristics of this plant, are unique, and we don't know from where this arrived. It arrived spontaneously, probably brought by penguins, we don't know, but it succeeded to arrive by itself and invade. We eradicated it because Francesco Malfasi had the chance to find it in the field, recognized it. But this means that the threat for Antarctic biodiversity is very, very important. And obviously, this means also that Antarctica needs to develop protection, so protected areas, protection by the environmental impact of humans, because we are one of the most important threats for Antarctica, and climate change, obviously. But I am among the scientists thinking that recent climate change is due to the human impact, so we are the core of the problem. Obviously in Toolik Lake, so you can have a better idea of why we selected this site that is so significant in the global frame of the research on climate change and the activities that we are carrying out. So there's no cover monitoring because this changes soil temperature, the conditions, and so on. And all the activities that you have seen and that Mauro and the students that I thank for their nice presentation shown you during the previous speeches. And I would like to underline also the link between Alaska, Antarctica, and the Alps, because even here in the Alps, the problem of climate change is very, very important. And it is changing our landscape, our territory. But as you know, plants don't speak, don't run, don't fight. So it's a silent revolution. But when you become aware of this revolution, it's too late. So indeed, some of the papers that are showing that this revolution is already occurring due to climate change are of our research group among the others. And so this is a network that we are trying to establish thanks to our university and the cooperations that have been made during these more than 20 years of activities. And thank you for your attention.
Thank you, Nicoletta, for the large overview of our activities. And now I wanted to invite Professor Maurizio Biasini to explain what he is doing in Washington. I suppose that you are there.
Yes.
Okay.
So, good evening, everybody. Thank you, Professor Guglielmin. Thank you for inviting me at this very interesting and important event. So thank you to Professor Tagliabue, Magnifico Rettore. I think that the Professor White is not commented, but to all the representatives of the University of Alaska. I will try to tell you in really few minutes, also because I'm separating you from your dinner, why I am talking to you from the Embassy of Italy in Washington. So first of all, to reassure you, I am a colleague. I am a professor of physics at the University of Perugia, but I'm temporarily on leave from the university and working for the Ministry of Foreign Affairs as scientific attaché at the Embassy of Italy. And I'm particularly glad to say a few words today from here, first of all, because we are living a historic moment, which clearly demonstrates how scientific cooperation is key for responding to cross-border challenges, from the pandemic to climate change we are discussing today and even beyond. Science at the same time is also, it is proven, the source of disruptive technologies, big data, AI, artificial intelligence, which is very discussed these days, but also quantum technology, future technology that are and will radically transform our economies and also society. From a national point of view, as you know, in this context, Italy, through the National Recovery and Resilience Plan, is promoting somehow unprecedented strategic investment in human resources and research infrastructures, like the 5 national centers on strategic areas or the extended partnerships, in order as a collective effort to facilitate collaboration among different national actors, both from the public and private sectors. In this context, of course, international collaborations are of paramount importance. They were previously based mainly on relationships among research groups or even individual researchers, but now are progressively structured through institutional agreements among universities, like the one you have signed last year, or national centers, or private sector, which in many cases, like in your case, involve many researchers and professionals from somehow different disciplinary fields. And from the point of view of cooperation between Italy and the United States in science and technology, this is really very solid. To give you a sense of this, there are over 1,000 bilateral agreements as of today signed between our academic and research institutions on a broad range of topics. And there is an estimate of about 14,000 Italian scientists and visiting professors who are working in the United States. And so our two countries, as trusted partners sharing the same values and visions for our future, Italy and US are working to strengthen this collaboration even further, and also in the most cutting-edge fields of science and technology. To this, what is the role of the Minister of Foreign Affairs? What is the role of diplomacy? Well, diplomacy must be fully engaged because scientific collaborations requires the joint efforts of scientists on one hand, but also science-minded diplomats or policymakers. And diplomacy can help both bilaterally, but also in multilateral fora, to foster scientific cooperation and really to tackle global challenges. At the same time, we can try to help and cooperate more scientists, researchers, and business of countries like Italy and USA. Our scientific office at the Italian Embassy tries to play an active role in strengthening bilateral science and technology collaboration, facilitating cooperation between subjects from the two countries. And furthermore, we try to support strongly the Italian scientific community in the United States, in particular important network of researchers like ISNAF. I want to give you this example, which is the Italian Scientists and Scholars in North America Foundation, which was established back in 2007, and today brings together more than 3,000 scholars, researchers, technologists from Italy, Italian who are working in the United States. From the formal point of view, last January, we had in Rome the renewal of the formal Italy-US agreement on scientific and technological cooperation, which dates back to 1988, and it is renewed every 3 years. So in Rome, the two countries, the two governments, has defined the new strategic priority sectors for our two countries, and these include physics and astrophysics, quantum technologies, natural disasters and climate change, agri-food, health and life science, and ICTs. So in particular, we are trying also to strengthen cooperation in the field of emerging technologies. And within the framework of this joint declaration, the Minister of Foreign Affairs has co-funded 18 projects for the coming 4 years in these priority areas, and for a total investment of about 1.5 million euros. And with regard in general to innovation policies, I would also like to remind that the Italian government has very recently established in San Francisco Innovit, which is the first Italian innovation and culture hub abroad. It's a sort of a unique platform for promoting translational research, startups, and also venture capital. In addition, and we come now to the role of science attaché, given the growing importance of science diplomacy, the Ministry of Foreign Affairs and International Cooperation, in accordance with the Ministry of University and Research, has recently decided to expand the network of scientific attaché, particularly in the United States. So indeed, we have one space attaché here at the embassy, and soon we will have a total of 7 scientific attaché, 3 here in the embassy, and 4 in the general consulates of San Francisco, Boston, Chicago, and Houston. This somehow should guarantee a more effective and capillary support to our scientific communities like yours, and further promote bilateral initiatives in science and technology. In particular, regarding climate change, Italy and US has established since 2013 a formal bilateral working group on earth science, and over 200 researchers from Italian and US universities, research agencies, are actively participating. And since the project in Subria Polar, which was so nice to hear details today, is definitely relevant for this working group, I strongly encourage, as already did with Professor Guglielmin, to contact the working group co-chairs and present there your activity. And as Mauro mentioned, your work, your project has been really very well received from your recent presentation at the event organized by the Embassy Switzerland, together with us, the Climate Innovation, USA Meets the Alps. Let me mention last point, I believe that the exchange of students and postdoc, which is a key element of your project, is also an area of paramount importance for the Italian system, for the Italian university. The recent rankings, results on rankings at European and international level clearly show that on average, we are lacking on the internationalization of our university. So I believe that your initiative is really paramount importance as a brilliant example of student exchange in the education sector. And so I invite you to promote even more this aspect. And so regarding this, let me briefly finish on a personal note. When I was watching and listening to your students from TÜLIC, and in particular the undergraduate student taking measurement there, I could not avoid going back with my memory to July 4, 1989, which was the date I arrived in the US. I was a third-year student of physics at the University of Perugia, and thanks to an exchange problem, I was able to start preparing my undergraduate thesis there, taking measurements in that case on cosmic rays for accelerator physics, so a different field. But anyhow, I think that this is a real great added value which goes beyond the technical education of students, but is really of paramount importance to help educating our future generation. So thank you really very much for this opportunity, and I can assure you that we as scientific attaché here in the US are here to help promoting, consolidating agreements, or expanding your brilliant activities. Thank you so much for your attention.
Thank you, Maurizio, for your kind words, especially at the end, about our project. And we hope to have the chance to cooperate also with the embassy in the next future. So I think that we can finish the event with some questions, if there are in Alaska or here for our students, so or for all the relators. And so I ask also to our students to connect again. Also, are there any questions? Ci sono domande? Posso dire in italiano che siccome fa freddo, no, c'è sempre il gelo e quindi le persone non amano molto le domande. We have a question from Professor Zamperetti for the students.
I have a silly question. Have you seen any bear in that place?
Yesterday.
3 bear. Really? Yeah. Be careful. Okay, thank you very much for your presentation.
You're welcome. Thank you for the opportunity.
So, I think that we can finish here, and mi raccomando, continuate a lavorare adesso al posto che...
Ma lavoriamo sempre.
Sarà fatto.
Sì. Nella sauna magari. Ciao.
No. È chiusa.
So I want to thank you, Donie, that I see also still on the screen, and Amanda. And I hope to see you again quite soon, maybe in Varese or in Como, or next year in Fairbanks. Okay, so thank you very much.
Thank you very much, Professor Biasini. Thank you for your support to our project.
Thank you. Thank you very much for inviting me, and enjoy your evening. Thank you so much.
Bye.
Bye.
Ciao.
Bye. Ciao, Mauro.
Bye.
Bye.